All right, today we're doing something a little different. We're going to unbox one of the most important toolkits in all of modern technology. We are prying open signals and systems to really see the concepts that make every single device you own actually work. So let's get into it.
You ever stop and wonder about this? Really think about it. How do our devices make sense of all these invisible waves of information that are flying around us all the time? We're talking Wi-Fi, GPS, the music streaming to your phone. There's this constant invisible conversation happening. But what language are they even speaking?
Wow, that's it right there. It is a language. And Signals and Systems, this is the course that teaches you the grammar, the vocabulary, everything you need to know to speak it fluently. It's what turns all those abstract waves into real, concrete information.
So, if we're thinking of this course as our toolkit, then the syllabus, well, that's our instruction manual. Let's take a look at the blueprint and see what these tools are actually designed to help us build.
Okay, the course objectives spell out the mission pretty clearly. The whole point is to really master the basic building blocks, signals and systems, and then learn to see them in totally new ways, like in the transform domain, which, trust me, is like putting on a pair of frequency-seeing goggles. It's also about learning the rules of the road for these signals and this absolutely critical process called sampling. That's the magic step that turns the smooth, real-world waves into digital data.
And here's the payoff. The outcome isn't just a bunch of facts in your head. It's a new set of skills. After you get the hang of this toolkit, you won't just recognize signals, you'll be able to analyze them, flip them between different domains, and know exactly which technique to grab to solve a problem. It's the ultimate before and after picture for an engineer.
All right, let's really get to the unboxing. The first tray in our toolkit holds the essentials. These are the foundational tools from the first 3 modules that you're going to be using all the time.
So, first up, the most fundamental piece of all, the signal itself. You can think of signals as the alphabet of this new language. Module 1 is all about learning to classify them. Is a signal continuous, like a sound wave, or is it discrete, like the pixels in a digital photo? Getting this down is step 1.
Now, building on that, Module 2 hands us our first real power tool, and this thing is a total game changer, the Fourier transform. It's kind of like a prism for signals. You feed it a complex, messy-looking wave, and it splits it apart into all the pure, simple frequencies it's made of. You get to see all the ingredients.
And this is the perfect way to think about it. Every time you tune your car radio, you're doing a real-time Fourier analysis. You're telling the radio, hey, ignore everything else, I only want to hear the frequency at 98.7 FM. The Fourier transform lets us peek into this hidden dimension, the frequency domain, and it changes everything.
Module 3 is all about rules and translation. First, we meet LTI systems. The best way to think about them is as reliable, predictable machines. What you put in now gets the exact same result as what you put in an hour from now. They're consistent, and that makes them the bedrock of signal processing. But the real star of this module is the sampling theorem. This is the mathematical key that lets us turn a smooth analog signal, like the sound of my voice, into digital ones and zeros without losing the original information. It is literally the bridge to our digital world.
Okay, so now that we have the fundamentals down, we get to open the next tray in our toolkit. These are the advanced instruments from modules 4 and 5, the specialized tools for the really complex jobs. So this slide lays out our new specialized tools. Look, the Fourier transform is fantastic, but sometimes you need a different wrench for a different kind of job. That's what Module 4 gives us, the Laplace and the Z-transforms. If Fourier is for analyzing steady, continuous waves, the Laplace transform is for looking at how a system behaves right when you flip the switch, those unstable first few moments. And the Z-transform, that's our digital multi-tool built specifically to analyze the discrete, step-by-step signals you find inside a computer.
And finally, Module 5 gives us 2 really cool precision instruments. First, you've got convolution. The easiest way to think of this is like a filter. It's the math that lets us predict exactly how a system, say a noise-canceling circuit, is going to shape any signal we pass through it. Then there's correlation, which is basically a high-tech signal search engine. It's how your phone's GPS can find a super faint satellite signal buried in a sea of cosmic noise. It's looking for a perfect match.
So, you've unboxed all the tools, you've learned how to use them. How do you actually prove you've mastered this stuff? Well, that's where the final exam comes in. But I want you to think of it less like a test and more like a final certification process.
Just by looking at the mark distribution, you can see what the focus is. Part A is kind of the warm-up, right? Just 10 marks. But Part B, that's the main event. 50 out of the 60 total marks are in these big, deep dive problems. That's where you really show what you know. And the structure of Part B is really designed to test how well you can apply the whole toolkit. For each of the 5 modules we just talked about, you get a choice between 2 big 10-mark questions. This means you can't just be good at one thing. You have to show you're proficient across the entire subject.
And that right there is the key takeaway. This exam isn't about memorizing a bunch of formulas. The way it's structured forces you to look at a problem, analyze it, and then select the correct tool from your toolkit to solve it. The right transform, the right property, the right theorem. You have to think just like a real engineer would.
Okay, let's zoom out for a minute. We've seen the tools. We've seen how they're tested. But why does this specific toolkit matter so much once you leave the classroom and step into the real world?
Because this isn't just a course. It's the foundational knowledge that makes almost everything around us possible. We're talking medical imaging, 5G communication, digital music, artificial intelligence, you name it. Mastering signals and systems is basically learning to speak the native language of the 21st century.
And that really just leaves us with one final thought. We've just unboxed the engineer's toolkit. We've seen all the instruments inside, from the basics to the advanced tools for analysis and design. So the only question left is, what are you going to build with it?